Ladies and gentlemen, I would like to welcome you to this session on future trends and innovation in mining, extraction, and processing technologies. My name is Roland Gauss. I work as Head of Innovation and Business Intelligence at EIT Raw Materials, and I have the pleasure to guide you through this session today. We have an exciting program of speakers from industry who will share their views on latest developments in mining and processing. We have today with us Sophie Lebouy, who is R&D Program Manager at Eramet. She will join us online. Sophie, are you already with us?
Yes, I am.
Okay.
Hello, everyone.
Hello. Great to hear. Great. We'll have Bernd Schäfer, CEO at EIT Raw Materials. We have Anders Sand, who is Research Manager at Boliden Mines, and we have Markus Heupel, CEO at the company About. But before we dive deep into the subject matter, I would like to hand over now to Joaquim Nunes de Almeida, who is Director at DG Grow and responsible, amongst many other things, but for mobility and energy-intensive industries. So he will give a welcome note.
Thank you very much. Is it my turn, therefore?
Yes, please go ahead.
Thank you very much, and congratulations for your Portuguese accent. The ladies and gentlemen, welcome all of you to a morning program that we hope will be inspiring and constructive, and that deals with key aspects of the competitiveness of our raw materials industries and downstream industries, moving forward towards the twin transition, green and digital. Yesterday, the Center of Excellence that is Europe in terms of research and innovation in raw materials was showcased to us. We have invested 600 million euro through Horizon 2020 for innovative solutions in raw materials exploration, mining and processing, and programmed 300 million euros of calls for the first 2 years of Horizon Europe. Now, this massive knowledge is something that builds the base for future developments, linking industry, academia, and research, which are crucial for an endeavor like ours. During the first session of the event, labeled Future Trends, Innovation and Skills for Raw Materials, chaired and led by EIT Raw Materials, the largest global innovation community in raw and advanced materials, we will learn more about the most relevant future trends in innovation and mining, extraction, and processing technologies. This includes increased circularity and examples of applications where our raw materials industries are part of the solution. Indeed, for our ambition to deliver the Green Deal and roll out clean technologies and digital applications, we need access to sustainable raw materials. This enables EU industry to be the world's climate frontrunners and to remain strong and competitive at a global scale. This goes for primary as well as secondary raw materials. We highlighted in the Critical Raw Materials Action Plan of last year that circularity and recycling of raw materials from low carbon technologies is an integral part of the transition to a climate neutral economy. We will continue to support research and innovation in new mining technologies, substitution and recycling under Horizon Europe and national programs. In fact, bringing research and innovation to market enables future sustainable raw material supply and the digital transformation and cutting-edge technologies where Europe excels, adds momentum, speed, and opportunities. Critical to supporting the twin transition is ensuring that the workforce will have the right skills to support it, and that structural changes are collectively anticipated and managed. As highlighted in the co-creation process of the transition pathway for the energy-intensive industries that we launched in September, This is necessary to achieve a just and successful transition. The transition will require a major and sustained reallocation of labor across sectors, occupations, and regions, as well as significant investments in re- and upskilling, retention of existing workers, and attracting new workers. All this is going to be hard. The nature and scale of these challenges varies among the different sectors of the ecosystem. We've got the example of the European batteries value chain, where industry estimates that by 2025, this growing skills shortage could amount to some 800,000 jobs across the entire battery value chain. 800,000 jobs, the size of a mid-large city. The skills challenge is part of session 2, developing skills and expertise in mining, extraction, and processing technologies, also chaired and led by EIT Raw Materials. I very much count on knowing more about how industry and academia join forces to address the skills challenge for the twin transition, getting to the skill needs in raw materials industries and how to empower people to transform ideas into solutions to raw material challenges. Therefore, ladies and gentlemen, and to come to an end, I think I can speak for all of us that we have an interesting 2.5 hours ahead of us and look forward to the discussions. Thank you very much for your attention, and thank you all for making this week a success.
Thank you very much indeed for this introductory speech. And with no further ado, I would like to ask Bernd Schäfer, CEO of EIT Raw Materials, to talk about the power of raw materials. And I would like to remind everybody we have the possibility later on, after the talk, to have 15 minutes of questions, Q&A, from the floor here, but also via Slido. So please use this opportunity. So, Bernd.
Yeah, thank you, Roland, and thank you, Joachim, for the introduction, which was very impressive. So, dear participants of this year's Raw Materials Week, a warm welcome to all of you, and thanks to organizers. Happy to be kicking off this morning's EIT Raw Materials events on future trends, innovation, and skills for raw materials. Technical content to follow, but I wanted to put this into a broader context. The context of the power of raw materials. But for anyone who is not familiar with us, allow me to start with a short introduction on EIT Raw Materials and IRMA. EIT Raw Materials is the world's leading partnership on raw materials. We develop Europe's raw materials talent and technology. Our community solves cross-value chain challenges. We are part of the EU agenda based on our expertise. We have above 300 KIC partners, which stands for Knowledge Innovation Community, and above 600 IRMA partners, so of the European Raw Materials Alliance. Our Knowledge and Innovation Community collaborates with partners from 22 EU countries, plus 10 countries being part of IRMA. We have 16 locations across Europe, with 4 more to be built by 2027. We are headquartered in Berlin in Germany. And in 2020, we have been mandated by the European Commission to manage the European Raw Materials Alliance. Okay. So why are we doing this? Why do we all need to care and proact the forthcoming developments and anticipate the transition needs? Recent reports underline the urgency of action on climate. However, COP26 and other climate action discussion often fall short of also highlighting raw materials needs. It is simple. Meeting the green targets require raw materials. There will be no Green Deal without raw materials. In fact, key decarbonization projects are impossible without access to raw materials, which makes raw materials are the nucleus for Europe's future. But the power of raw materials to create a green economy, to support digitalization, to drive prosperity is currently underestimated. Raw materials are vital for our power supply and to power our transport and industry, and they will become more so. They are essential for the immense electrification targets and the ramp-up of non-fossil energy generation. Raw materials are therefore an indispensable enabler of the green energy transition. Okay. To give you an example of this, the International Energy Agency predicts that in terms of gigawatts, renewable energy demand will increase 6,000-fold by 2050, an unimaginable number, which becomes very tangible when translated into volumes and type of raw materials. The demands for raw materials necessary to build, for example, wind turbines, will consequentially increase massively. There will be an unprecedented volume need for many critical and base raw materials to realize the transformation from a linear brown to a circular green economy. In the transition to clean energy, critical minerals bring new challenges to energy security. An energy system powered by clean energy technologies differs profoundly from one fueled by traditional hydrocarbon resources. Building solar, photovoltaic plants, wind farms, and electric vehicles generally requires more minerals than their fossil fuel-based counterparts. A typical electric car requires 6 times the mineral inputs of a conventional car. And an onshore wind plant requires 9 times more mineral resources than a gas-fired power plant. Since 2010, the average amount of minerals needed for a new unit of power generation capacity has increased by 50% as the share of renewables has risen. So the shift to a clean energy system will drive a huge increase in the requirements for metals and minerals. No? Doesn't work. Raw materials are the nucleus for strategic technology and sectors in the EU. Demand for primary and secondary raw material will rise. According to some scenarios linked to the green and digital transitions, Europe would need almost 60 times more lithium and 15 times more cobalt by 2050 for electric cars. The demand for rare earths used in permanent magnets could increase tenfold. In the same period, they are critical for products like wind generators, electromobility solutions. The EU lacks domestic production. We rely heavily on imports of these materials from a small number of third countries. China provides more than 90% of the EU's supply for rare earth elements. Turkey provides 98% of the EU's supply of borate. This makes us vulnerable to supply chain disruptions, especially for raw materials with high and very high supply risks. Next. Just a few examples. Can you go to the next slide? It doesn't work here. Okay, thank you. Just a few examples. Turkey supplies 98% of EU borates. South Africa provides 71% of the EU's platinum needs, and China 93% of magnesium. The latter is already causing a supply crunch and severe downstream issues, last but not least to the European aluminum industry. To date, the discussions still mostly revolve around the price of raw materials. What we should discuss, though, is the price of not having access to these critical materials. The potential for Europe to produce and recycle more of the raw materials needed for its energy transition is huge and untapped. The transition to a circular economy is essential in the efforts to reduce dependency on raw materials supply and create sustainable growth. We are committed to supporting and enabling the shift to a circular economy across the raw materials sector, which will be crucial to Europe's decarbonization efforts. A radical shift is required from linear to circular thinking. End-of-life products must be considered as a resource for another cycle, and the interactions between materials must be considered to define the best circular solution from a systemic standpoint. And of course, awareness of the benefits of closing material loops must be realized in society. All if this will not happen without education, innovation, and investment. Our focus as EIT Raw Materials and IRMA. So the power of raw material supply is not evenly spread. We need to take the power back. We need to boost innovation, which means to integrate smart ideas, investments into the raw materials value chain and skills for future. EIT Raw Materials and IRMA are working towards this goal. The session today and during this week are proof of that. While we are here, I'd like to invite you also to join us next time in Berlin for the Raw Materials Summit 2022, one of the largest raw materials events in the world. And in the meantime, we have a brilliant range of speakers lined up for you this morning to discuss future skills, innovation, and trends for raw materials. Thank you for your attention.
Thank you very much indeed for this inspiring presentation. And as I mentioned before, take your notes, take your questions, write them down, put them on your notepad or upload them into Slido. We will have the chance to discuss later. Our next speaker is Anders Sand. He will talk about future trends in mining and raw materials processing. The floor is yours.
Thank you very much for inviting me to talk a bit about what we are working with Boliden, but what also applies very generally, I think, over the industry of metal production. Actually, one of the biggest challenges I had with preparing this talk was that we have so much ongoing. I think it's something like 100, 150 different types of innovation or implementation projects of new technology. Anyhow, I will try to give it some level of justice by bringing out a few examples from different parts of the value chain. So I will take a bit of a value chain approach to this talk. All right.
Just indicate, say next slide.
All right.
If
It kind of works, but okay. Yeah, we'll see. Otherwise, I will ask the help upstairs. So in terms of exploration, I thought I would show this example related to using augmented reality in visualizing ore deposits. With augmented reality, you actually can impose some computer-generated structure onto a physical structure. So you see an example there from an open pit. But then, of course, also inside your own office, you can work with geological models. This project is actually funded by EIT Raw Materials, so thank you, Bent, for that. Otherwise, there's a lot of work also ongoing related to drill core scanning and using machine learning, artificial intelligence, and so on. So there's a lot ongoing in geosciences. Then maybe now it's changing automatically. So we even have autonomous slide changer. I would like to make a parallel to space exploration when we are moving into talking about autonomous mining vehicles. There are actually a lot of similarities. You have operation in remote places. You are not maybe able to move there manually and do interfering with what the equipment does. You need to have accurate positioning and good communication with the machinery, and if there is not communication, if it's interrupted for some time, then you need to be able to have it operate efficiently also without operator control. We sometimes make the joke that it's easier to go to Mars than to work with autonomous vehicles in a mine, and I guess that can be debated, but the reason also for showing this is that actually NASA approached us and wanting to learn about what we are doing with our mine automation program and what they can do with their next generation of space exploration vehicles. So I think we are not as conservative as we think sometimes. Now, yes, changing slide. So of course, with bearing also to what I showed you before there, you have a need for electrification and automation with remote control and autonomous operation. You need certain infrastructure with networking and positioning systems and so on. And all of this applies in mine automation. Then there's also different things ongoing related to instrumented rock bolts for monitoring tensions in the mountain, and also to monitor seismic activity and so on. Another interesting thing related to explosives, developing fossil and nitrogen-free explosives. And also I think you have heard before about using drones for monitoring in mines, both underground and in open pits. So these are a few more examples of ongoing trends. Then I have a few examples actually. We have been working in the Aitik mine in northern Sweden, as well as in Kevitsa in northern Finland, and in the Kristineberg project, now an underground mine, on electrification using trolley systems. So here we are able to do quite a lot of saving of fuel consumption. You see some numbers there, almost 1 million liters of diesel per year in the Aitik pilot project. And then with full implementation up to 14 million liters. And then we have the projects also at the other mines. So very exciting activities there. Related to autonomous vehicles, the automated loaders were, I think, the first project we started. There are very clear benefits in terms of productivity. You see that on the graph there, that a traditional mining operation would be the light blue color there, but with an automated system you can cover shift breaks and lunch breaks and so on. So you get a huge boost in efficiency. And the operator you see there on the picture, he's not actually, he's running the trucks, but he's teaching them how to run autonomously. So he will teach one to drive, and then he will let that one go and teach the next one, and then do like that. So one operator can run multiple vehicles at the same time. And this is implemented already. Then we come to an ongoing implementation project of automation in production drilling. 2016 we had 7% automated drilling. Now we are up to 60% this year in the Garpenberg mine. We noticed that we will drill a lot more meters with this automation, and we can have a lot fewer people doing it. And also a very strong benefit is that operators actually like it. They can be more social, work as a team, have better conditions in general. So it's also good for in the workers' context. Then an example of a project on more of development stage, automated charging using a robot. This equipment is a stationary prototype at this moment, but the next step is actually to put it on a vehicle so that it can move around to charge in different places. So also a very exciting project. Then with mineral processing, there's a lot of activity happening in terms of doing more energy efficient comminution, moving from tumbling mills to high-pressure grinding rolls or dry comminution concepts. Different types of geometallurgy optimizations also related to big data in this context, optimizing the mine operations. Working with flow sheet flexibility to be able to handle different ore types in the same plant with optimum efficiency. Also different pre-sorting concepts such as sensor-based sorting. And digital twins, this is very important when you have a number of operators and you want operators basically to learn from each other. Then you can use artificial intelligence and different types of model approaches to give recommendations how to operate the process in the best way given the conditions at the time. In terms of flotation, we are actually watching something of a technology shift now. For a long time, the trend has been to increase efficiency by increasing the size of flotation cells. So if you go back a few decades, the cell size was maybe some tens of cubic meters, and now we are up to almost 1,000 cubic meters in the largest cells. But this seems to change now. There are different equipment coming to the market now with much lower footprint but maintained efficiency. And you see an example there from the Garpenberg mine where we have been calculating on an alternative flotation cell concept that uses about 1/4 of the footprint of the traditional mechanical cells. Also different concepts related to resource efficiency by enhancing fine and coarse particle flotation. This is something that actually most equipment manufacturers are working with now in different ways. Also novel reagents for better health and safety and also from environmental concerns, so replacing reagents by better ones, ongoing, and a lot of collaboration with different chemical suppliers here. And of course all of this requires a lot of sensor technology in equipment, also artificial intelligence and model predictive control systems. So we have such systems implemented partly now in both in flotation and in comminution circuits. Then you can ask yourself that how has all of these things that we have been working on, have they been beneficial for the efficiency? And I think actually this figure illustrates it quite well. So the brownish dots there, they are actually Boliden mines, and the ones that are really outliers there in terms of productivity in the global mining market, they are the ones with the highest level of automation and with the most process adaptations for efficiency. So I think we are doing something right, and working with innovation is really something that can benefit also the bottom line. In terms of environment, there's of course constant efforts. That's nothing new, but it will be more and more of this also in the future, minimizing emissions, also dealing with tailings in various ways. You know about the dam accidents in Latin America. This has of course started a lot of activity also in Europe to look at alternative concepts for dam safety and also maybe avoiding dams altogether by dry stacking or other techniques, or productifications of different residues, both like minor volume applications like extracting residual metals, but also bulk applications. Product labeling and tracing of origin of raw materials is also something more and more mining companies are working with. You see two examples here from Boliden with introducing low carbon copper and also recycled copper labeling. Then of course climate change is very high on the agenda with the Green Deal and the Fit for 55 concepts that have been coming lately. It's something we have been working on many years actually before the Green Deal, but it has intensified our efforts. So we are looking at CO2 minimization, and many of the examples I showed previously with electrification and fossil-free explosives are part of the work we are doing. Then maybe something interesting that all of you are not aware about is that tailings actually naturally can absorb carbon. So we are also looking at this potential there, either active or passive carbonation of tailings. And of course, as has been said already many times during this meeting, that mining is actually an enabler of green transition and circular economy. So even if we are working with lowering our footprint, we are also enabling others to lower the footprint. Next one. Then some challenges. There are of course always a lot of technical challenges, but at least in my experience we are usually able to overcome these, and it's less of a problem than different types of political or legislative challenges, and also the social license. In my mind, the mining industry in Europe, it has never been more environmental friendly and socially acceptable in some ways. But the social acceptance is actually kind of decreasing in Europe. Also the permitting processes are getting ever slower and more unpredictable, especially in Sweden. And I think this is actually, I would call it so bad that it's nearing a system collapse. So we will see how that how it will move forward in the future, if something will happen or not. Otherwise, there will not be too much mining in Europe anymore, I think. Then, of course, access to land issues and recruitment that we will also cover during the session later on. Up. And then a final thank you for this talk, and I included a quote actually from a Swedish authority that was appealing one of our mining permits, and it tells something at least about the huge knowledge gap between industry and authorities, and also maybe lack of understanding of raw material issues. So I will finish with that one and then look forward to the later discussion. Thank you.
Thank you very much indeed. I was very much impressed by this comparison of mining technology development in Mars rover. So maybe at some stage you will offer your mines as a test site for Mars rover. But let's discuss this later on in the panel discussion. I would now like to hand over to Markus Heupel, who will be talking about remote process and process monitoring solutions in mining and processing.
Good morning, ladies and gentlemen. So thank you for the invitation to present about in front of that auditorium. It is quite impressive what Anders Sand spoke about Boliden and his 150 project that he is responsible for. So about just does one project, and that is what I want to tell a little bit in more detail. But what we have in common is that innovation is the key to be more efficient and to raise and gain operational efficiency. So I brought with me a healthy approach of digitalization in mining, and that means that we think about how to tackle the complexity, or what is complexity of mining processes. What's our approach to tackle that? And we also will see some market-driven use cases in mining to go really in detail and see how we could do that and go on. Okay, it's a full page already. So why? Now it jumps automatically. Okay. So why do we do mining analysis in mining. So we have the problem that in mines and quarries, the available data are not used in a huge extent, so just little effort is done to get relevant operational data, and they are even not measured or analyzed. But they give an enormous potential to increase the operational efficiency. So when you think on operational information, so why do we lose data? Why do we lose the possibility to analyze them? First, data are not captured. We just don't measure them. Data are not streamed or stored. They are sitting on the machine. They are sitting in the processing plants, and then they are not accessible out of different reasons because there are data insulas. Then they are not analyzed, and if they're not analyzed, the next problem, if they're analyzed, then they are not communicated, so it doesn't help if you do nice analysis and you don't speak about them. And finally, data are maybe too complex, too difficult to understand, and they are not used in decision making. And that's is what we as About try to do for the mid-sized and small mining industry, to have an innovative IaaS, information as a solution, to tackle this performance gap. And finally, when you look on the right side of this slide, you see the 5 most important aspects in those mines. So you have to really have a close look on the production and mass flow, how the site is organized, how your fleet, what's the fleet's efficiency. A huge issue is idle times and inefficiencies according to CO2 footprint. And finally, of course, communication and reporting. We now make a jump into a mine. Unfortunately, the movies are not running, so there are a lot of movies embedded here, so you should see all these nice pictures now moving, but just let's have a look on that. So when we think of a mine, we start with the deposit, we think on that. Then we do the drilling and blasting, then different activities for loading with hydraulic excavators or wheel loaders. Then you need to think on the transport cycles, and finally intermediary stockpiles and processing plants. So that's the full setup that you need to think about once you try to optimize a mine and once you try to give an innovative solution towards the industry. So how can we now start to get this information? Yeah, now it's on. So we start with reality capture. So automating it near real-time data capture, that's important. So it needs to be automated. No miner needs to do something manual. So you need to collect the data in a very good way and in real time. And that should be suitable for all the processes that we have seen before, for internal processes, but also for subcontractors. So there are the 3 main steps that we do. So the reality capture, and on the lower part of the slide, you see some possibilities for mobile mining machines. We collect, let's say, a kind of moving patterns, how these machines move and how they act, to automatically get the activities. That's done with artificial intelligence and machine learning. So we have a huge team that is just doing that, artificial intelligence and computer vision. Also, images nowadays give a lot of information. So we place cameras on neuralgic places, or we use drone places. So all these data that are collected and captured are analyzed uniquely and combined, so no matter the source. And out of that, we are able to get an AI-driven recognition analysis of the mining processes on site. And finally, and that's the most important thing, all this information is given to the mine foreman, to the mine management, so that they are able to gain visibility on every aspect of the mining operation. And out of that, they then can take decisions and improve the operational efficiency. When I speak about use cases, so all these theoretical things and how we collect the data are brought into specific use cases in mining. You can see these 6 use cases. So once we get the data and the insights and we improve the decisions and gain efficiency, that is done for operations monitoring. So how is the operation running, when there is a break and something like that. The production progress to monitor the quantity, the quality and the mass flow. Fleet efficiency to check the machine utilization, cycles and loading times, the idle times and inefficiencies. Then to define specific KPIs, reportings, and also that is one of the last things that we realized what's important. Once you collect data and you have them for more than several years, you can start doing nice investment decisions because you know what your machine has been doing, so you just go back, look in your data, and derive what you want to do in future, and you have objective information on that. One specific example, also that should be nicely visualized, so you should see all these columns now running. So what we do is we try to make, let's say, management-proof visualization so that everybody in the mine, from the foreman up to the top management, understands what is going on in the mine. And you see here that we try to really visualize all the data that we have, not only in some tables, so really 3D animated with all the information that's important to understand. So once again, here you see the mass flow over time. That could be done fully automatically, the tracking of the loading and unloading activities. Also the quality management, that means we combine all these loading and unloading activities with the quality of the mine. And finally, we do a standard reporting that is done in a dashboard like you see it here, or automated export to the customer IRP system where they needed to do their specific analysis. For fleet management and operations, these analyses that you see here was for a long time not accessible for the mid-size and small mining industry. So our target is to bring these techniques and artificial intelligence towards those mines, so that allows them to really have a look on their fleet management, what are the cycle times, what they could do, how the operational efficiency could be improved. So just giving them means to improve their mines. Support investment decision. Also here, that's just to do a decision of the exchange of one wheel loader. And that picture that you see here is for a time span of 2.5 years. What the wheel loader is doing during that time. So where he is loading, where he's driving, so you get really full information on that machine, and that allows you just to calculate and see, okay, do you need a bigger one, do you need a smaller one, do you need to exchange it against an hydraulic excavator, something like that. So, we also have cameras on these machines, so you can compare what the machine is doing against the working conditions if he's loading huge, medium, or small-sized muck piles. So finally, there will be a dashboard for mining monitoring. So also this should be animated to you. Could have seen more on that, but it's just a static slide right now. So all this information that I spoke about before and that what we analyze is shown on a dashboard. So there is a starting page that shows the most important information for the mine foreman. But if you want to know more and want to investigate more, you just click and drill down and down. And this picture on the right side, for instance, gives all the loading points. So these green dots are all the loading points where a loader loads material to a truck over the last 90 days, and also the machine that run around. So that is fully analyzed automatically using artificial intelligence algorithm in the background. One topic that we realized is heavily asked meanwhile is automated recognition using computer vision. We started meanwhile 3 years ago to train different vehicle types, truck types, to fully automatically recognize them in the mines, and that's one example. We are able to give information on if trucks are fully loaded or empty, where machines are going, what they are doing, and we mean that's, if we speak on innovation, a very important part to take into consideration, not only sensor data, but to combine that with computer vision and camera data. So thank you for your attention. And when we speak about data, so move mountains with your data. Thank you.
Thank you very much indeed for this very, very impressive presentation. And yeah, so we're moving forward now to our final speaker, and that is Sophie Louis, who will join us from, where are you located actually? From France.
I am in France, yes, near Paris.
Okay, so the floor is yours, Sophie. Very much looking forward to your presentation.
Okay, thank you very much. Can't see my slide. Okay, perfect. Thank you very much. Thank you for this opportunity to present today two great innovative programs that Eramet is leading and that are fully supported by EIT Romateo. This is the EGELI program and the RELIEF program. And next slide, please. I will start with next slide. Sorry. With few words about Eramet. Eramet is a major player in the extraction and the transformation of metals, and today this is what we are talking about. And we are present in 20 countries. We are more than 13,000 employees, and we have location 36 mining and industrial sites. So next slide, please. Yes, we have historical mine of nickel in New Caledonia and manganese in Gabon. And we have also nickel activities in Indonesia. In Europe, we have mainly the refining activities for manganese product and nickel product. And in South America, we have a project for lithium production. From Salar's brine that has just restarted for the construction. Next slide, please. So Eramet is also in complement with this primary and large project, is also involved in two European programs, the EGELI and the RELIEF projects, to produce battery grade products for the battery industry. I think there is some animation, if you can click, please. Just so the EGELI program. Next slide, please. Yeah, you can click. Yes, again. Thank you. The EGELI program has started in 2019 and will end this year. The RELIEF program has started in 2020 and will also end this year. There were upscaling programs. It means that we have done a lot of tests at pilot scale. And to do that, we have gathered a large consortium of European players, and we have received a great support from EIT Raw Materials. Next slide, please. So I will start with the EGELI project. So EGELI stands for European Geothermal Brine Lithium. Next slide. Thank you. And a few words about the benchmark for this lithium project. In Europe, you have a lot of lithium production projects, mainly from spodumene or lepidolite, so hard rock projects. Few are fully integrated towards the production of hydroxide of or carbonate. And you have also a few programs concerning the lithium valorization from geothermal brine, Eugélie, also Vulcan Energy that is located in Germany and is also targeting the same reservoir, natural reservoir. We have also Fonroche in Alsace, in France, and in the UK, an interesting project that actually combine the production of lithium from spodumene and also geothermal brine with the project Corniche. Next slide, please. So Eugélie intends to connect the process that has been developed by Eramet for the Argentinian project to the geothermal plant. So initially, the process for lithium extraction is already an innovation from Eramet, since it is very different from the conventional process of lithium from salars that is based on natural evaporation. This process is based on direct extraction. So the brine goes through a column that is filled with a special tailor-made material that will capture only lithium. And then this column is eluted using water, and so it releases lithium into a concentrated lithium chloride solution. And this innovative process is the one that is being industrialized at the moment in Argentina. So there is a training center that is producing lithium carbonate at the moment, and that will be the process for the future plant that should start in 2024. So the idea of Eugélie is to connect it to a geothermal plant located in Alsace and operated by Électricité de Strasbourg, our partner. Next slide, please. Thank you. So this is an innovative process, but it's even more challenging to adapt it to the Alsatian brine. First of all, because the brine composition is different. So in terms of operation, it has to be adapted to a lower lithium content, to different composition in terms of other components. There are specific components related to the fact that this is a geothermal brine, especially there is a dissolved CO2 in it. And we don't want to remove this CO2 into the atmosphere, of course. We want to keep it in the brine. And also, there are the process and all the equipment have to be adapted to the specificity of the geothermal activity. So the high temperature and the high pressure. So it's above 20 bars, and the temperature where we want to plug the lithium extraction is about 80 degrees. Next slide, please. Thank you. So at the moment, as we are speaking, we are carrying out a pilot campaign in Soultz-sous-Forêt. This is the equipment you can see on the right part of this slide with the three columns that they are filled with this tailor-made material. And they allow the production of this lithium chloride concentrated solution. At the moment, we have produced more than 3,000 liters, and they are right now treated to be further purified and also concentrated prior to be transformed into lithium carbonate. Next slide, please. So a few words now about the other project that is the Relief project for the recycling of lithium-ion batteries. There are many reasons to develop this industry of recycling. First of all, because the volume will be very important. And you can see on this slide that we are speaking about more than 300,000 tons of volumes to be recycled by 2030, and this is reasonable assumption. And also because we need to develop European-based recycling industry that will be compliant with the requirement of the European battery regulation to efficiently recycle these batteries and to also recover specifically these strategic metals that are the components of this battery for electric vehicles, especially nickel, cobalt, and lithium. Next slide, please. So at the moment, there are many challenges to develop this industrial chain, this full industrial chain, because at the moment there are not this volume. So at the moment we can see there is the black mass producer in Europe, but mainly all the black mass produced in Europe is exported outside Europe to be refined using pyrometallurgy. So if we want to develop here in Europe, we will have to overcome technical barrier, and it takes time to develop this type of projects. Next slide, please. So we have worked on this technical barrier through the RELIEVE program. And we have developed and tested at pilot scale of end-to-end recycling solutions. So from batteries towards the production of metallic salts for the production of new batteries, a closed loop solution. And for the upstream parts, so meaning from the batteries to the black mass production, we have tested this process on multiple and various type of feed, entire packs, modules, cells, cylindrical pouch cells, prismatic cells. And also we have done a lot of work on gigafactory scraps. The process that we have been developing as high recovery rates for this black mass. And also what is important is a very high quality black mass. It's important because at the moment the black mass, as I was mentioning before, is sent outside Europe to be refined using pyrometallurgy. And tomorrow, if we want to do hydrometallurgy to produce battery grade metallic salts in Europe, we need to do it on a better quality of black mass. So concerning this hydromet process, we have tested it from end to end also with excellent leaching recoveries above 99%. It allows, of course, the lithium recovery compared to the pyrometallurgy solution. It allows the recovery of graphite, and we are working with a partner to further valorize this graphite residue. And we have obtained the battery grade quality for all the strategic products of this battery component. Next slide, please. So this is the flow sheet we have been testing at pilot scale, and from the modules to the battery grade product production. This is what we can see also on these slides. It's that we have been testing each step to be sure to be on target with the European requirements for the recycling activities. Next slide, please. So this is what Eramet wants to develop and to propose to the industry in Europe. It's an end-to-end activity from end-of-life batteries and scraps towards the production of the metallic salts for the production of new batteries. So it will be for the black mass production, and then the black mass refining. It doesn't have to be at the same place necessary. And what is important also is that we have this possibility, because of our other activities in Indonesia, New Caledonia, and so on, to complement the feed of the refinery with raw material. So to combine black mass with raw material that have the same type of composition that contains nickel and cobalt, and to have a sufficient volume for this refinery to make it profitable. Next slide, please. Yes, next slide, please. I think it's yeah. Thank you. So this slide presents the project development timeline. We are finishing this year the RELIEF program. Thanks to the support of the EIT raw material, we have done many pilot campaigns. We have now a technical, we have now the flow sheet that is well defined and tested, and we know the performance of this flow sheet. We also, thanks to this program, we have demonstrated the attractivity of this project, and we will go further and push to the engineering and industrialization phase between 2022 and 2024. So it means that this project should start a construction in 2025, which is well aligned with the market development of end-of-life battery to be recycled. Next slide, please. And well, this is my last slide for this session. So there are challenges to develop this battery metal production in Europe. If we look at, for instance, the lithium production, the European resources are rather small compared to other Australian mine or Argentinian mine, and therefore the investment is important for this type of project. However, they are quite competitive in terms of Opex. For the EGLI project, is well positioned on the cash cost curve for lithium production, and also it can have other competitiveness advantage, such as a very low CO2 footprint. If we look now at the recycling activity, it's very attractive as it is, but the key to the success will be the accessibility to the materials, and this is an industry that is not mature yet, and that needs to be structured and well structured so the black mass stays in Europe. And to address all these competitiveness issues towards large players, towards Asia, towards large mines, we believe at Eramet that, of course, innovation is a key, and the EGLI program and the RELIEF program have been a success, both, and that the technological breakthrough are keys for these European projects. And there is also a strong need to have a partnership approach to be integrated in the current market in Europe to develop this innovative, competitive program into a circular economy. And thank you very much for your attention, and I'm looking forward for the question.
Yeah, thank you very much indeed, Sophie. Very, very impressive presentation, and really this integration of primary sourcing and sourcing from recycled materials and integrating all this is very, very impressive. We now have the opportunities for questions and a little bit of a discussion. So I would like to invite people to come up with questions. First, we start here in the floor. Are there any questions? I see someone in the back there.
Thanks for all the panelists for interesting perspective. This was a question to Anders. You see there is increasing resistance to the mining in Europe. That's bad to hear. But we have been doing, at the Commission or also the EIT, last 10 years of work popularizing the raw material field. So it's a kind of contradiction to see that there's also increasing number of regulations. So these 10 years of work has not reached to the level that we wanted. What is your opinion?
Does it work? This? Okay, good. Yeah, to me it's kind of interesting because if you look at Europe, we probably have the best potential in the world to mine in an environmentally friendly way and taking into account social factors and handle all part of the processes very responsibly, but still have very low acceptance and also decreasing acceptance. And it's something that I have problem answering too. I'm working mostly with technology development, so maybe some social scientist or something should look a bit further into this. And also I think maybe to some extent it's also our own fault historically that of course all projects have not been handled well. There's been accidents in Europe as well, so you need to take the history into account. So I guess it's kind of a mix of everything here. I hope it answers your question somewhat. Yeah, one other comment as well that I mean safety in mining. We talk a lot about safety to motivate different projects, especially underground automation and so on. And maybe the more we talk about safety, the more unsafe people feel that mining is. Although it's getting safer, and it's about as safe as working as a clerk in a clothing store. So that's the level of safety right now. But maybe it is about communication to a large extent.
Thank you very much. Is there another question? Yeah, I see another question over there.
Thank you. My name is Thomas Tranek. I'm from Maracay Magnesita in Austria. We are operating underground mines, and I'm very interested in the presentation from our colleague from Sweden. Thanks a lot. One question in detail: we get in Europe much stricter NOx limits, especially for underground mines. I have seen in your paper, and you mentioned it, you are working on nitrogen-free explosives. Can you give us a little bit more insight in that? It's a very interesting issue. Thank you very much.
Yeah. So these nitrogen-free explosives, it's actually explosives that are based on peroxide instead. So basically it will end up as water at the detonation. One motivation for this is production related, that you have less need for mine ventilation if you use these explosives. Also you normally have undetonated explosives in the mine that comes up with the mine water, and then you need to do nitrogen treatment. But by changing the explosive you can avoid this. We have had, I would say, escalating costs for water treatment, partly due to higher demands on the treatment, and also when you increase production, normally you are not allowed to increase emissions. So at some point this becomes unmanageable, and you have to kind of rethink the whole process. That can you do something totally different. Then maybe another challenge related to this is that something also that we didn't know, and that is that most of the peroxide actually is produced from fossil fuels, same as hydrogen, now when we are talking about the hydrogen economy. So it seems also in a way that every stone you turn, you end up with some kind of CO2 footprint you have to think about. So there are also challenges.
Okay, thank you very much. I would have a follow-up question to Marcus on this subject matter of social license to operate and resistance to mining. Do you think that, I mean, your very impressive visualization approach and technology. Could this help maybe also to steer the debate into the wider society?
I think yes, so it helps to visualize what miners are doing, and sometimes it is just hidden in underground mines what they do. So also open pit mines are not also very dangerous areas for just the public to go there. So bringing pictures to the public, nice pictures to show them what's going on, and that this industry does not differ to any other production industry. So by just showing that we are producing something valuable and we do it with newest technology, with good innovation, we do it with a huge responsibility. And if we bring it to people, yes, I think that would really help getting them an insight in that what we are doing. And if people have insights, then I mean, there is nothing to worry about it anymore.
Yeah, so to actually visual or bring people closer to this rather remote industry sometimes, right? Using these technologies.
Exactly.
And in this context, I would like to mention that we actually have it at ENT Raw Materials, a so-called Raw Materials Academy with also a wider society learning program. So that maybe this could be also an interesting way to connect. And yeah, Bernd, do you want to comment?
Sorry, yes. I have a follow-up question here to my colleague to the right side, because when I was seeing all this impressive data management, and today everything is about data, and not only intrinsically oriented towards operational excellence, I was just wondering, we have this huge discussion in mining about social license to operate, how to create trust. Wouldn't this data be an excellent tool to proactively and preventively being used to create more trust around, let me say, the society and the population that is around mining? So kind of treating the data in a mining system similar to a nuclear power station. Because this would, in my view, be an enormous trust provider next to, of course, all the operational excellence considerations of using them internally.
When we speak about data and that's what we do, there are two sides of the medal. The one side is that people are anxious that they work in the mine. Yeah, it is really transparent. It is very transparent what happens and what we are doing. So we need to speak with them that what we do will help others to understand what they do. And once we overcome that problem, that say, yes, we are willing to show them very transparent what we do, like an atomic power plant. Yeah, so. And you see really everything what's going on, then I would say yes. Once people know that we collect many data and we treat them and speak very open, let's say on an open data platform or whatever, that could definitely help to raise the awareness on that what we do and think, yes, the miners are quite well.
Thank you very much. And let's have a look at the questions from Slido. So there's a question to Anders. Can you please share info on the impact of the automation on the Opex of the mines you mentioned?
Yeah, it is lowering Opex, and that's of course part of doing these investments that we are doing. I should also mention that a lot of this work that I presented, it's work we are doing together with our suppliers, so using our operations as a test bed and evaluating. So we also kind of have the first understanding there of the potential economic impacts and whatever challenges related to different technologies. But it's of course always an economic consideration. And we are not doing projects that we feel that it's not paying off within reasonable time.
Thank you very much. I also saw previously a question to Sophie in the online sheets. Could you bring it up again? I cannot read it because of the timer. You have to remove the timer. So market measures, Sophie, market measures needed for secondary raw materials for batteries, price competition with primary could hamper interest from industry. So I guess it's all about scalability, it's about cost, and do you think you can compete?
Well, it's a very good question. Yeah, it's all about the scale, of course. And if you look at the recycling project I have presented to you today, we are targeting a sufficient scale to make it profitable. And we do think that the Hydromet refinery will be even more competitive with a nice combination of primary and secondary materials refining. So we need to compare what is comparable, recycling with recycling. I think, yeah, really one issue for Europe will be to do this large-scale refinery. Don't know if it answers the question.
No, definitely hints in the right direction. That will be the key challenge, right? To really scale up these technologies, not only in remote places somewhere in the world, but really in Europe. And this is really also our mission at EIT Raw Materials, to boost innovation, accelerate, the smart ideas really reaching the market and train people accordingly. Thank you very much. With this, I would like to close this panel. We're a little bit over time already. I would like to apologize for this. Thank you very much to all the speakers. It was really a pleasure to have you here and to join. And thank you to all those who really raised questions and for the good discussion. Thank you very much.
So, welcome everyone. Please come in if you're joining the skills session, and please have a seat. Hello, welcome everyone. I have to admit it's a bit odd to be standing in front of people after almost 2 years. But I would like to thank the conference organizers for organizing this skills session at Raw Materials Week 2021, and also to all the speakers who have joined us online, but also in person, as well as the audience members. My name is Wesley Kroc. I'm the head of education at EIT Raw Materials. And together with Jenny Grieberg, the associate professor of mining and rock engineering at Luleå University of Technology, and the program director of the Swedish Mining Innovation, we will be presenting to you our perspectives on skills in this session. Then after we finish speaking, please feel free to ask questions in the audience. And for those who are joining us online, please use the Slido to ask your question in the Slido. Before I start, I would like to understand who I'm looking at. So please raise your hand if you're coming from a university. Ooh, interesting. Raise your hand if you're coming from industry. Raise your hand if you're coming from policy. And raise your hand if you're coming from neither of what I've expected or what I've said so far. Okay, very good. Well, so I'm here today to talk to you about the education strategy at EIT Raw Materials and the approach that we take to education by addressing the entire life cycle of innovators. And I was happy to see all of these really interesting projects that were presented earlier today. But all of these exciting projects, they were developed by people, and they will not be implemented unless we also secure the supply of people to implement these projects. So I'm also going to emphasize a few things that have been said this morning, but I'm not going to spend a lot of time on it. But in order to achieve carbon neutrality and safeguard that we live within a planet, within planetary limits, but also ensuring that we leave a planet that is livable and healthy to future generations, we recognize that we have to transition from this brown take, make, dispose economy to a green and digital economy. This was evident also at the COP26 last week. And as mentioned by my colleagues this morning, the building blocks of this transition are indeed raw materials. They will power the evolution, as fossil fuels will then be replaced by rare earths and other technology metals for the energy generation and transportation, for advanced materials, for example, for electrified mobility. But there's also inherent challenges to make this transition a reality. We have to secure the supply of both primary and secondary raw materials, but we also have to design material solutions. We have to close loops and integrate circularity, resource efficiency, and reduce material intensity in our processes. For this to happen, we need a workforce with the right skills and attitudes, but also the political will to seize momentum, to harvest opportunities out of these challenges. So, will we seize these opportunities fast enough to secure supply for our carbon neutral ambitions? That's the question. As mentioned earlier today, and a key theme throughout the week, we have to then secure the sheer volumes of raw materials needed to deliver on these targets. Not only will the production of lithium that will be needed by 2050 in order to achieve these carbon ambitions increase by 965%, but the question remains, where will this lithium be produced? Where will the lithium be processed and manufactured into goods and services? Where will the value be added? We need to continuously invest in innovation like those projects that were presented earlier today, but we also need to invest in education to ensure that the skills that we need are swiftly put onto the market to ensure that we can also swiftly and sustainably source raw materials. So it wasn't talked very much about earlier today, but what about secondary raw materials? To deliver on climate ambitions, we can also diversify our supply sources and substantially improve our production of secondary raw materials, not only to recover the resources, but also to recover the embodied energy. So how are we performing in Europe? Well, you see lots of orange and red on the screen on the periodic table. For these elements, we have an end-of-life recycling rate of less than 10%. This is coming from the JRC in a 2018 report. 32 of the 47 elements with a recycling rate less than 10% have been identified as critical raw materials. So this means that their supply risk is high, but so isn't their economic importance to Europe. Many of these elements are also key to seizing our climate ambitions. Therefore, we can diversify our supply if we also tackle the secondary raw materials challenge. According to a study carried out by Fraunhofer within the context of the ETIP project, global battery production will dramatically increase over the next 9 years. According to projections, and this is important, for each gigawatt hour of battery production, there will be 90 direct jobs created and over 300 indirect jobs created. So people are really going to drive this battery transition. But we don't want to solve one security of supply problem, namely security of raw materials, and end up with another security of supply problem, namely the security of skills, the security of people. So we have to invest in these technologies and innovations. This is key, we know this. But we also have to ensure that we have a sufficient workforce with the right skills and an aging population so that we can achieve our climate and digital ambitions. It also makes economic sense to invest in education. This was highlighted by the first speaker of the session this morning. This is especially a salient opportunity where we can also invest in places where geological boundary conditions are favorable, such as the Western Balkans, but also in the Nordics, for example, where new sustainable and inclusive economic ecosystems can be built up. Between 30,000 and 90,000 jobs could be created by 2030 in the battery supply chain. This could be increased in 2030 to 36 to 90,000 jobs that could be left unfulfilled if we don't do enough now to invest in education and invest in skills. So we in EIT Raw Materials, we unite partners from business, from higher education, and from research to invest in innovation projects, but also to invest in education projects to ensure that we secure supply of raw materials, but also ensure that we secure the supply of people. We aim to really empower people to transform the ideas that they have into innovations, bringing research out of the lab, bringing education and entrepreneurs to Europe. As our CEO mentioned this morning, we are the largest global partnership on raw materials that unite more than 300 partners from all sides of the knowledge triangle, so from higher education, from business, and from the research community. We also take a holistic, integrated approach to raw materials with our investments and partnership covering the entire value chain. So from exploration geology to the extraction of raw materials, to their processing, finally to their manufacturing, use, and post-use activities. But we need solutions also that take this full value chain approach into consideration. And a perfect example is design for recyclability. So if we don't think about the post-use activities, in the design phase, we could end up with products that are not easily recyclable and therefore secondary materials not easily recoverable. We also invest in a series of activities in EIT raw materials. We invest in matchmaking events. We invest in startups and SMEs. We also invest in innovation projects like those highlighted this morning, but also education projects that are implemented by our partnership. The EIT raw materials strategy addresses this entire life cycle of innovators from the wider society, so this is schools and pupils, to higher education, this is master and doctoral education, to lifelong learning. A reason that we really reach out to schools and are involved in schools is because often the decision on a career is made very early in one's life. So in order to ensure that one can attend a technical university in the Netherlands, for example, one has to already start to study a track in high school that would then prepare them for a technical university. So really addressing pupils at a young age is critical to ensuring that they forge a career in raw materials. But our goal is really to create a robust, systematic pipeline of talent that delivers people from schools to higher education, all the way through to upskilling in industry, to present this skills shortage that was highlighted earlier. So how well are we doing in EIT raw materials? Well, we've educated more than 200,000 learners since 2016. Considerable efforts have been made in our schools activities and our wider society learning programs. And this is because the economy of scale are there. It's rather affordable to educate the public through awareness-raising campaigns, but also to educate pupils in schools. However, degree education, the education of highly skilled talent, this is costly. And we need also the will to be able to invest in higher education degree programs. But we need these graduates because they're not only going to fill the jobs, but they're going to also continuously evolve the sector and create the projects that were presented earlier today. And this is why we've created our master's school of raw materials related degree programs that are delivered by the university partners of EIT Raw Materials, and thereby unifying raw materials education in Europe. Our programs cover the entire value chain, from exploration geology in our Emerald program to mining engineering in our EMC program, to material science programs, but also recycling degree programs. So we really also represent the full value chain that our organization takes also in our master's school. We're going to add more degree programs to our master's school based on the thematic gaps and also the needs of the market. And we actually need everyone to be able to tell us what the scope and learning objectives should be of these degree programs. But in total, more than 670 students have enrolled in our degree programs since 2016. So what are the principles? So how is our master school different from conventional master programs? The message is that we deliver excellent degree programs which are innovative and equip people with the necessary knowledge, skills, and attitudes, distinguishing them from other graduates from other programs. For example, all of our degree programs require international mobility to one other university. We also require all of our degree programs to have 24 ECTS of innovation and entrepreneurship education. We also require all of our students to do an internship with industry. This is also key. And we also require all of our students to carry out thesis research that is co-supervised by both an academic supervisor, but also an industrial supervisor. So what does our master school look like? The message is really that we try to unify our students in addition to the program. So we actually bring together all of the students from all of these degree programs to participate each semester in one particular entrepreneurship-focused program that we then organize. The goal is really to bring together our students with our EIT raw materials innovation and partner ecosystem to match the opportunity seekers, which are the students looking for jobs, looking for internship opportunities, looking for thesis projects, with our industry, who are seeking out talent. Moreover, all of our activities are challenge-based, which means that the challenges that they are working on in these innovation and entrepreneurship programs are sourced from the industry. So they're working on real industry challenges. And one of the examples of one of these activities is the Raw and Circular Economy Expedition, or the RACE. It's a 2-week learning journey along the entire value chain of raw materials, where 70 master students move together over 2 weeks to key industry stakeholders representing the supply chain of raw materials for future mobility. And this is what the structure of the race looked like when we were able to travel. We started off, all 70 students, all of our experts, at Outokumpu in Finland to see the mining activities. We then moved in a plane to Audi to look at then the plant operations and all of the activities taking place at Audi. We also then moved to the city of Rotterdam to take a look at the use phase of mobility within a city setting. And then finally, we ended up at Umicore, where we then focused on the end-of-life recovery opportunities. Unfortunately, because of COVID, we also were unable to replicate this physical program in 2020 and 2021, but we virtualized it. And it became a 3-week challenge-based learning journey across also this entire supply chain of raw materials for future mobility. And we also integrated the main components. So we had live keynotes, we had a hackathon, we had networking with our industry partners, we organized HR sessions with our industry partners, and also had virtual tours. And these are just a list of the partners that have been involved in the race since 2019. So it's really key players: Atlantic Copper, Outokumpu, Cornish Lithium, Emeris, Northvolt, Audi, Umicore, Boliden. So really key players that are involved in this supply chain. We also have educated an awful lot of students. I believe it's more than 530 students we've educated through the race, who've also developed more than 20 startup solutions to the challenges coming from our industry providers. And one of the highlights of the RACE program is Impact PCB. Impact PCB was a startup solution created by a team of students at the RACE 2020. They were responding to a challenge from Atlantic Copper. Then the RACE took place, and the students then pitched Impact PCB solution to this Atlantic Copper challenge. They won the Global Digital RACE 2020. They then moved to EIT Raw Materials, where we provided support and mentoring to this team, and they then submitted a startup idea to a startup contest called the EIT Jumpstarter. They also, Impact PCB and its solution, were involved in an innovation project. They successfully submitted an innovation proposal to EIT Raw Materials, and more than 4 million euros was awarded to this project. And finally, they've made it to the final of the EIT Jumpstarter, which is this cross-kick startup contest. Another important program is Girls Go Circular. It's a gender diversity and STEM program that involves 3 other knowledge and innovation communities. And in 2022, it will then be increased to 7 innovation communities. We are the coordinator of this program, and it's highly strategic for DG AAC. We've been entrusted by DG AAC to deliver on Action 13 of the Digital Education Action Plan, in increasing women participation in STEM. So far in 2020, we've trained more than 2,500 girls, and by the end of the year, we will train another 5,500 girls. And by 2027, our aim is to educate more than 50,000 girls. So what is this program? The program uses the circular economy as a vertical topic to learn about digital skills, the horizontal topic. Moreover, the circular economy is the programmatic element that brings cohesion to the entire program, which is used, the circular economy is used as a solution to address the societal challenges addressed by the other knowledge and innovation communities. So circular food systems, circular manufacturing, circular innovations. So through the commitment from the schools and teachers, pupils learn digital skills with a view to the circular economy in an online program. And the importance is we really want to inspire young people, and in particular girls, to forge a career in raw materials that will then address this potential skill shortage that we could face in Europe highlighted earlier. And then the final program that I would like to highlight is the ROMAT-COP program. It's actually being presented in a parallel session, the Copernicus session that is happening right now. So ROMAT-COP is a 4-year program that's co-funded by DG GROW and EIT Raw Materials. It started off in 2017 and it just ended this year. ROMAT-COP aims to develop the skills, expertise, and applications at the intersection between Earth observation data and services in the raw materials sector. And the way that we do this is through a research value chain approach. So we've invested in 13 postdoctoral projects that are addressing real case studies from the industry. The postdoctoral researchers have to bring the industry to the project. And particular topics that they're looking at are not only the technical side of the project, but they're also looking at uptake drivers such as economies of scale, environmental impact monitoring, safety, and increasing transparency in the supply chain. And then finally, the goal is to also transform these research findings into a lifelong learning program called the ROMAT-COP Academy, where we then transfer this knowledge then to other target groups. So these are some of the projects that have been carried out by our postdoctoral researchers. So really looking at the instability in open pit mines, looking at the monitoring of mining dust through Earth observation data and services, to detecting informal alluvial mining in Colombia, for example, together with the UN. And then the ROMAT-COP Academy is then the outcome of all of these research projects. So we target large industry, so managers, R&D, but also executive leadership, technology providers, so startups and SMEs to large industry, but also other startups and SMEs. And the researchers are really working on raw materials topics and also environmental monitoring of similar industrial activities. This program has been designed to be delivered face-to-face, but also fully online. And we deliver it on demand. So if you come to us wanting to organize this Earth observation training for your company, please talk to us and we can organize it for you. So far, since 2016, it's been delivered 7 times in 4 countries, and we've educated more than 160 professionals. And here's just some links where you all then can get involved in our activities, but also contact us if you have any further questions. And finally, as highlighted by Bernd, our CEO this morning, please then save the date for our Raw Materials Summit in 2022. And with that, thank you very much, and we will then move on to Jenny. Thank you. Hello, good morning, Jenny.
Good morning, Wesley, and thank you very much. And first of all, thank you to the whole team for providing me with the possibility to participate remotely today. That was great. And also, hello to the audience, ladies and gentlemen. Really sad not to be able to meet you in person, all the colleagues, but I think this might be good enough still. So I will try to talk a little bit about actually sort of a snapshot of the current situation that we are facing now, and then some suggestions for solutions for this. So please, the next slide. Yes, this one's correct. As we have heard, and as you all know, there's a lot of things happening. We are in the middle of a changing scene. We are in the middle of a green transition. And we know also that this green transition requires an increased volume of metals and minerals. In fact, we know for a fact that the speed of the transition is directly proportional to the need of metals and minerals. We know also that even with 100% recycling, we would need to increase the primary sourcing in order to meet the needs. As you can see on the image to the bottom right there, we use more elements than ever as we develop technology that we need for the green transition and a sustainable future. We also know that there's been an increased focus on sustainability, on all aspects of sustainability, but also, of course, to focus on environment and climate effects. We also need to have an increased focus on resource efficiency in order to do this and use the resources that we have in the best possible way. And we're also in the middle of all this, living through this process of digitalization and automation in most industries. So there's a lot of things going on. It's an exciting time, and I think all of us being in the middle of this will look back maybe 10 to 15 years ago and realize how fascinating it was and how great it was. But we really need to work now and work hard. And next slide, please. Let me see, it's a bit of a delay. Yes, this one is right. What we did 2 years ago, we gathered some of the top management of the Swedish companies related to raw materials, the CEOs, some of the CTOs, people responsible for HR and so on. And we tried to understand what the main challenges for our industry was, given the challenges that the society is facing right now. And this group ended up with this result that we have 3 main challenges. The first one is, of course, technical development, to be able to do this, to have mining operations that are productive enough and sustainable enough to do this in the speed and with the quality that we need. The second one is social acceptance, and we talked a lot about this. We heard Anders in the previous session talk about that we have a decreasing social acceptance for mining. And we see that this is a big challenge, not only when it comes to the society's views on this, it's also permitting processes, and it's also very much related to the competence and skills supply. We need to create a better view of the raw materials sector in order to attract people. So please, next slide. So after having identified these challenges, we realized that we really need to do something with supply. So I will try to now talk about where we are now. We started this intense work in Sweden 2 years ago, where we tried to really dive deep into this question: how are we going to be able to supply our industry with the competence we need? And when we also try to create a roadmap for this. And the first version of this roadmap was published in 2019. And currently we are developing an edited version of this one. So we'll produce the next version early 2022. So please, next slide. So what we know so far, and in this slide you see the word critical, and you can actually somehow equal this to when we talk about our critical raw materials. We tried to list the critical core competence that we need but we don't have enough of, and also the multidisciplinary skills that we need. And we also made a short list of the critical labor categories that we have. And although this is information from Sweden, all Swedish companies are hiring on a global market. So we see this as a global result. We see the same critical competence also outside Sweden. So basically, it's all through the value chain, as you see here. We need more people with geology expertise, with geochemistry, with mining, metallurgy, processing, and environmental. So all through the value chain, especially as an example, when it comes to mining, we know that we have a big shortage in Sweden of mine planners. We know that mines are becoming deeper, they need to be more efficient, but we don't have enough people educated in mine planning. This is a traditional area and topic, nothing new, but we still can't have enough people working in this field. What is new from when we looked at this approximately 10 years ago is that we also feel that critical core competences are computer science, programming, machine learning, automation and robotics, and also energy. We see that our mining operations and also metal producers need more of these type of skills, much more than we had approximately 10 to 15 years ago. And we also see that our equipment suppliers, such as Sandvik and Epiroc and all the other European suppliers as well, also have these shortage skills. I shouldn't say impossible, but it's extremely difficult to find programmers in Sweden, and I know that this is true for many European countries as well. And what about the skills that we need? When developing this list, this was done by a big team in Sweden. It was representatives from all industries, from most of the universities, and also from the institutes in Sweden, who had different workshops and try to understand what we need and what we don't have in order to be a bit proactive. And when we talked about the skills, we said that we could have used the word circularity, but we didn't, because for us circularity should be in everything. But we need to develop the skills that enables the workforce to have a holistic view of whatever we do. We have to think long, sustainable value chains. We have to think circularity, and we have to think the big picture. And this is not as easy as it sounds, maybe, and it's not easy to train the students to do this. And when we look into the educations that we have today, this is not focus. We're getting better, but we haven't had focus on this in previous years. We also need the skills to be able to combine technology areas. So what we call hybrid competencies, as for instance, production technology and materials technology combined with either mechanical engineering, energy engineering, electrical engineering, or computer science. And so we see these hybrid skills becoming more and more important. And this is, of course, a result from us also working more and more in collaboration when driving innovation and the technical development. So in order to collaborate with suppliers and with others, you need at least basic skills to be able to talk to them and to be able to order the stuff that you need and talk the same language. We also see that this short list, if you see in the bottom here, of critical label categories, this is actually a short list where we already in 2019, and we have updated it a couple of 6 months ago, where we actually couldn't find people. It's quite a long short list. It's metallurgists, it's mechanics, it's industrial electricians, civil engineers, environmental engineers, computer scientists, automation engineers, system developers, and IT engineers. And what's also important to remember is that this is not only critical for our industries, this is also critical for the authorities that are dealing with our industry. For instance, in the permitting process, we need competent people at the authorities dealing with the permits to both to have mine production, but also to create new products and to develop new deposits and also to extract new materials. And the sad fact that we see in Sweden now is that we have extremely long processes, and part of that problem is due to lack of staff at the authorities with the right competence. So please, next slide. So this big group of people from our Swedish industry then pinpointed 4 main challenges related to this skill supply. Of course, to attract new persons and to keep the existing workforce that we have in our industry. This is also a growing challenge. We know that the younger people are more prone to change. Perhaps our parents and the people that are now in their 70s, they came to one employer and they stayed there throughout their life. Now we know that the young people are moving around much bigger extent, so we need to find incentives for them to stay in our industry. And also another thing related to what's new and to the young people of today, the demands on them, of course imposed by the demands of the society, is changing quite rapidly. So we need to be able to train them due to the changing needs of the industry and the society. So we need to secure relevant higher education, and this means not only having the right programs, it means actually having also short courses and also maybe question the whole system. Is it sufficient to have 3 + 2 years for a bachelor and a master? Should we have a shorter? Should we have modules? Maybe we need to sort of revolutionize the whole education system because things are happening and changing so fast now. Of course, also, as we've seen really good examples presented by Wesley Kroc that EIT Raw Materials is doing, to increase collaboration between the education system and the industry. This is key. This is mentioned by all industrial partners and all universities. And offer non-traditional education options, not full-time, maybe for already professionals, they can study over long periods of time and so on. And a big focus on professional education and lifelong education. And then when talking about the next generation workforce, we know and this is also proved by science, that they are different compared to us. They have a shift in attitude and values. They ask in bigger extent for why they are doing things. They need to feel meaningful, and they need to find meaningfulness with what they do. They are often attracted to challenges. They want a high degree of responsibility, and they are prone to change. And this means that we have to change, we and the industry has to change accordingly, but also the education system has to change accordingly. We also discussed a lot about the locked potential that we have with low share of women and low degree of diversity. And I think Wesley also showed really good examples of trying to unlock this potential. And please, next slide. Now I'll try to show some numbers here. It's a bit of a delay here, but so please, next slide. Yes, this one. Here is current numbers of workforce demand and supply, a prognosis made for the Swedish situation. So what we see here is the blue line, that's the demand of engineers within chemistry, biomaterials, geotechnology, and mining. And what you see, the green line, that's the supply that we have, that we will pump out through our education system in Sweden. And you see an extremely big gap here is facing us. And we need to do something about this, of course. And we can't just change this by affecting individuals. This is something that we have to bring to our politicians and decision makers. So next slide, please. Here we see the number of PhD degrees with technology focus in Sweden. We see here that we actually have an increasing number. This trend has been obvious since 2015, and we have a slow increase every year, and we have no official numbers for 2020 yet, but in 2019 we also see a decrease. And of course this is worrying. We know that we need PhDs in order to solve the problems that we have. So please, next slide. So now talking a little bit more about this locked potential. The writing in the diagram is in Swedish, but I will try to explain it for you. The diagram here shows the share of female, which is in blue, and male, which is green, students in the for Sweden's industry most relevant high school programs. And the numbers are from 2019. And the high school programs are from top to bottom. That's the energy program, the industrial technical program, and then the technical program, and then the natural sciences program. So we see that we have a very big dominance of male students here. So already here, we also heard Wesley mention that in Netherlands, you need to very soon make your choices. And we have the same situation, or very early make your choices. We have the same situation in Sweden, and I know it's the same in many other countries in Europe. So already here, we sort of lose a lot of the potential that we have for future employees. So of course, females is a big target group. We must try to raise their interest in engineering and in technology related educations. Next slide, please. You can mirror this, of course, in the numbers that we have now for female employees in the Swedish mining sector. I don't know if it's super visible for you. It's kind of a small diagram, but in total in the mining industry in Sweden, we have a little bit more than 22% females. If we look at the white collars, that's about 32 or 33%. But mine workers is even lower than 20%. So of course, we have a big unlocked potential here. And in order to meet the challenges, we need to get to this potential. The females. So please, next slide. So the work that we have done in Sweden now for the last 3 years related to this competence supply has resulted in recommendations to 3 groups. One is recommendations to the industry, and this is what you see on this slide. What should they do in order to solve the challenge with competence supply? Well, yes, they should improve, or at least help and work for improving the image of the mining and raw materials industry and increase the interest for technology. This is something that we all have to do together, the politics, the society, and education system and industry. And to a greater extent offer internships and also continuous education to their current employees. Also open more ways to access the industry for the workforce. Short courses to train new workforces to move them from other industries into this one and so on. And then also very important when it comes to social sustainability, to help improve the attractiveness of the local society in the relevant areas. And of course, if people doesn't want to live where these operations and industries are, it's going to be extremely difficult to recruit. So these were the main messages from this work done in Sweden to the industry. If we move to the next slide, please, then we see the message to the decision and the policymakers. As we said, this is a bit of a system problem. We need the different governments and countries to secure relevant educations for the industry's needs. In Sweden, as it is now, we educate much more economics students than engineers, even though we know that Sweden as a country need more engineers. And we probably have the same situation in many other European countries. So the big question, I guess, is should we educate what the students wants to study or what the country's needs? Probably a mix in between there. But we need to secure the relevant educations and seats on those educations. And then enable and make sure that the education system offers more non-traditional educations, shorter and also directed towards professionals and other ways into the industry. And the same bullet here, support the relevant regions to make them attractive with infrastructure and with everything that makes a region attractive for people. And then support recruitment to science and technology. And this is also, we had this fifth bullet that I didn't show today, but that is also pushing, of course, resources into the innovation system related to mining and steel production and metals production to make sure that we actually support that system through public funding as well. And the next slide, please. And this was the message to the education system. Well, of course, also try to contribute to the increased interest for technology and engineering, to secure relevant higher education. Are we having a relevant education system, or is it too slow? Is it too difficult maybe to turn it around if we need something new? We know that the needs that the industry are expressing, in Sweden at least, we're not fit to change the system fast enough to meet those needs and change the content of courses and programs. It's a very slow and rigid system. And I know that's also the same for many other European countries. It's a very slow and rigid system. And again, this bullet to increase collaboration between the education system and the industry. Of course, this message goes to both partners. Offer these non-traditional education options and also focus on professional education and lifelong education. And that was my last slide. And I just want to end this by saying that taking this kind of snapshot on the situation in Sweden and in Europe today, it is kind of worrying. So we know that we have a sense of urgency when it comes to the speed of the green transition. We know that technology development needs to move in a very high speed. But as we heard in the beginning of the day today, I think we have an equally big challenge with actually providing people and knowledge into this system. And we are facing the fact that we have slow systems in the different countries in Europe. We can't change the education system so fast. So I think what EIT Raw Materials is doing when it comes to education, it's great. It's fantastic to see all those initiatives, but we need more. So that's my final message, that we have a big worry in Sweden, how we're going to be able to do what we need and attract people that can do it for us and with us. So thank you.
Thank you, Jenny, for providing this perspective from the Swedish perspective, which I think is also probably applicable to other regions as well. And I particularly enjoyed the very concise, practical action plan for different stakeholder groups. I'm sure that everyone in this audience will be happy to receive the slides at a certain point. So thank you. Let's open the floor for some questions. Please raise your hand in the audience if you have a question for Ginny or myself. Yes, the gentleman.
Yes, I'm Didier Zimmermann. I'm the Director of Education and Innovation at the IIT Raw Materials. I have a question for Jenny. I mean, you presented very well the core competence, the skills we would need. I mean, in the mining sectors, where are the main gaps today? We have education trainings working in different countries, and in Sweden, for example. Where would be the gaps between what we need and the skills and the competence we need?
Yeah, I have to be, sadly enough, all the, what I showed on that slide, that long list of core competencies, that are the gaps that we have in Sweden, the gaps that we identified. So, in fact, we have gaps all along the value chain. And like I said, it's a critical list that we showed, and all through the value chain.
Thanks, Ginny. Any other questions from the audience? On the Slido, there is a question that asks how EIT Raw Materials intends to retain talent within the EU, especially coming from the degree programs. So this is actually why we try to integrate our students and our degree programs in the EIT Raw Materials ecosystem. So during the education journey of a student, we systematically bring together our industry and our students to be able to prevent as many leakages as possible from this talent pipeline, so that we're really a source of value for not only the industry that are looking for the talent, and as you can see from Jenny's slides and also from my own slides, this talent demand will increase in the future, but also for the students. They are also looking for a job, and it's going to become competitive for these students. You're going to have to try to persuade them actually to join your company. So I think the points raised by Ginny, the values, the attitudes, what's important for a Gen Zer. Do you all know in this room? I see lots of people not from the Gen Z generation. I think it's important that we are also speaking and communicating to people in that age group and persuading them to join our company, because they do have different values. So I think that on the one hand, we try to bring the industry together with our students. On the other hand, we also want to, in EIT Raw Materials, persuade students from the chemical engineering sciences, from other non-raw materials specific disciplines to join also an EIT Raw Materials education program. Did this provoke any question from the audience? If not, there's one more question in the Slido, and then we can break for lunch. The final question is, what about education for primary school teachers and pupils? Sadly, not much geology, but we do need to talk about upstream activities. What I will say is this: please go to rmatschools.com. So we have more than 100 projects in EIT Raw Materials portfolio, in the education portfolio. Please go to rmatschools.com and you will find an education program for primary school teachers and schools that has been launched in I think 16 different countries, and therefore also translated in local language. And you will then find these programs for primary school students. And with this, I will close the session. I'm the last thing between you and the lunch. So thank you for coming to the skills session, and enjoy the lunch. Thank you.